This is Chapter 1, Section 1 on real numbers and the rectangular coordinate system. We're going to cover four main topics. We're going to talk about the sets of numbers that make up the real number system, and we will talk about the rectangular coordinate system, or it's just the XY axes. We'll also look at the distance and midpoint formula. First of all, sets of numbers. We're going to start with the smallest set, which is natural numbers. These are the numbers that we use to count with. If we were to write a set of them, it would look like 1, 2, 3, 4, dot dot, meaning continuing to positive infinity. So the smallest number in this set is 1, and the largest number is we're not able to identify. It's that idea of infinity. Another way to describe the natural whole number or natural numbers are positive whole numbers. Okay, the second set of numbers is integers. Integers include natural numbers, their negatives, and one more number, 0. So if we want to look at a set of them, we're going to be starting at negative infinity, so we start off with the dot dot dot, pick up with negative whole numbers, include 0, and then also include the positive whole numbers going up to positive infinity. Okay, if we were to represent integers on a number line, we would represent them with discrete points. All right, such as right here, we're 2 to the right from 0, so we would call that 2. Here we are 4 to the left from 0, so we would call that negative 4. Okay, integers are still whole numbers, but they include positives and negatives. All right, the next set of numbers is called rational numbers. Rational numbers can be written as a fraction of two integers. And we typically will refer to those two integers as P and Q. Okay, so in other words, a rational number is going to take the form of P over Q, where P and Q are both integers. So let's look at examples. Rational number includes 1/2. So 1 is an integer, 2 is an integer, and there we have the fraction of those two numbers, and so that's a rational number. We can have negative 17 over 23. That's a rational number. If we represent rational numbers in decimal form, the decimal form will terminate or, repeat. Okay, so other examples then would be like 1.5 or negative point repeating 3. Okay, those are rational numbers. All right, so integers are included in rational numbers. So we could refer to the integer, say 5, as 5 over 1, all right, which is the fraction of two integers, 5 and the integer 1. The next set is irrational numbers. So far, we have started off with natural numbers, which are included in the set integers, which are included in the set rational numbers. Irrational numbers do not overlap with any of those other sets of numbers. So integers are not going to be irrational, natural numbers are not going to be irrational, and rational numbers are not going to be irrational. So they don't overlap. So irrational numbers can be defined as numbers that cannot be written as a fraction of integers. So it's the opposite of how we define rational numbers. In decimal form, again, it's going to be opposite of how we defined rational. They do not terminate or repeat. So a lot of square roots or radicals are rational, such as square root of 2. So if we find the decimal form of that, that's 1.4142135 and we could continue to write numbers for the rest of our lives because that decimal does not repeat, does not terminate. Another famous one is pi. Okay, that would be like 3.1415925 ... Okay, so we use irrational numbers all the time, but typically not in their decimal form. We use them in these other forms like radicals and pi. Now we're going to put our sets of numbers in pictorial form. So we'll start with natural numbers in this rectangle. And then we will look at integers in a larger rectangle that includes natural numbers. So if a number is a natural number like 3, right, it shows up in the natural number set, but because natural numbers are in part of integers, it's also an integer. Then the set that includes those plus other numbers are rational numbers. Okay, make that a little smaller. Now, sitting next to the rational numbers, but not overlapping with, is the set of irrational numbers. Okay. The rational numbers and irrational numbers all together make up the set of real numbers. Okay, every real number is going to be either rational or irrational. And real numbers can be natural numbers, integers, like we said, rational or irrational. Okay. One other kind of number that we want to talk about just briefly, because it's not real, but we will encounter it, is the number that we get when we take the square root of a negative. If we take the square root of a -1, we get what we call the imaginary unit I, and it's not real. It's imaginary. So any any radical square root, any even radical of a negative number is going to be imaginary. So any number with I, all right, such as 3i, square root 2i, negative 5i, all those are not real, but they are imaginary.